Can you see the packet tracer again?
Yes.
Yeah.
Okay.
Packet tracer. So what I'm saying is that then I'm just showing a quick way of doing Cisco initially, and then enable class. Okay. Then I do config conf t. Then I can do a paste. I can copy my everything in my notepad file and paste it here. Then you don't have to type it. Once you have done one router, you only need to make the necessary changes for R2 and so on, and then copy and paste. This is quicker. I just want to show you this. So as we're doing this, now let's have a look at R1. Let's not have a look at R1. Let's go and have a look at S1, because S1 we haven't configured, and there's very few things we need to configure on a switch. Very few things. Conf t, and I'll show you what we need to configure. I've already done a notepad file with the configuration for S1. Did you see this? Did you see it? Can you see it? Okay, but I'm just gonna now paste it. I'm gonna paste it in the switch. Paste. What did I paste? I had the host name, the enable secret. Okay, certain codes I copied from the router which don't work with the switch, so it will be ignored anyway. So the enable secret is there, no IP domain lookup. This is the important one. Two things I want you to, everything else apart from the basic config, which is the same on whatever you do on the router, you can do on the switch. The basic config in terms of host name, no IP domain lookup, logging synchronous, everything within the banner. The only difference, perhaps, is when you come to the VTY. On routers, the VTY is from 0 to 4, the old routers. On switches, even the old switches from 0 to 15. But even on new routers, they have up to 15. So if you're configuring the 2900 series routers, even those ones, they have up to 15. So even this section will be the same between switches and routers. So apart from the basic config, what do we need to do on switches? Two things. A switch, in order to manage it, you need to give it an IP address. But you look at a switch. Let's have a look at switch physically. This is my switch physically. Yeah. I'm going to zoom in. Can you see in here an interface apart from those switch interfaces? Only switch interfaces. Switch interfaces on layer 2 switches, such as the 2960 switch I have, they're layer 2. They only work with MAC addresses. I cannot assign them an IP address. So where do I assign the IP address? There's a virtual interface. A virtual interface called VLAN 1. VLAN 1. Can you see this here? VLAN 1. Where is it? Up here a bit. VLAN 1. So instead of typing interface FA00, GI00, you type interface VLAN 1. This is a logical interface. And then you can give it an IP address and do no shutdown, just like a normal interface. Exactly. Same, but now the interface name is VLAN 1. And this is a logical interface. If you go to the physical view of the switch, there is none of those ports are called VLAN 1. They're called fast Ethernet 01, 02, 03, 04, and so on. There is no VLAN 1. So VLAN 1 is virtual, it's logical inside the switch. And this is where you give it the IP address. Why do we need this? Will the switch not work without this? No, the switch will work happily. But if I want to remotely access the switch from the network, I need an IP address. And you will see later on, as we build on this example, from the PC, from one of the PCs or any of the PCs, I'll be able to connect to the switch and configure the switch remotely. I don't have to be directly connected to the switch to do this operation, just like remote configuration of the routers. The second thing we need to configure on the switch is this command here. The IP default gateway. Now, a switch is a layer 2 switch. Because it's a layer 2 switch, it doesn't know if it receives packets destined to networks it's not configured with. It doesn't know what to do with. It will broadcast it generally. It will broadcast it out of all of its trunk links. This is not very efficient operation. Not very efficient. So if you want to tell the switch, instead of broadcasting those messages out of all of your available, let's say if I come here and It has currently this one here, this link here. This is a trunk. This is the trunk link between the switch and the router. A trunk. Or between one switch and another. It could be a trunk or it could be an access link.
What does the trunk do?
A trunk, it will carry data from all networks. We call them VLANs. We're going to cover this inshallah next semester when we talk about switching. But for the time being, all I want you to appreciate is that a layer 2 switch, we can actually control the broadcast in a layer 2 switch by creating virtual networks, virtual subnets, not real subnets. Because why? Because it's a layer 2 switch. Subnet by definition is related to IP addresses, and IP addresses are layer 3 concepts. So a switch layer 2 switch says, I'm layer 2, I'm dealing with MAC addresses. Why are you talking to me about IP addresses? So we do this by creating multiple virtual environments, where each virtual environment on the switch will correspond to a subnet or a network of IP addresses. Now, each network will have its own broadcast domain. So when these guys, they want to talk to each other, they say, we can't. We need, a switch cannot actually take information from one broadcast domain and relay it to another broadcast domain, because it's a different network. And it says, I'm layer 2, I don't understand about IP addressing. So it needs the help of a layer 3 device, such as routers or layer 3 switches, with an operation we call inter-VLAN routing. Also, we are overstepping ourselves. We're going with that, because this is going to be covered next semester, inshallah. So this concept of inter-VLAN routing is basically to allow switches to connect between different subnets. Now, for us, all you need to know for the time being, to have a proper configuration of a switch, this is what's required for you in the exam, is to add, oops, oh, look, died here. Okay, is to add those two commands. Let me just go back to the mouse. These two commands, the VLAN, interface VLAN given an IP address, and the IP default gateway. Can you notice something about the IP address I chose here for the default gateway and the IP address for the switch?
The same as the no subnet was 2. Wait, hold on. What happened? There's no subnet mask.
Where's no subnet mask? There's subnet mask here. Okay, tell me about this. What is so special about this IP address? It belongs to the same network here, to 192.168.1.0, same network. So this is something very important. The management IP address for that switch must be an IP address in that host range for that network. What about the default gateway? This is the same default gateway I will configure on PCs, which is the IP address of the router interface. Yeah, this router interface. Yeah? This is the same default gateway. So now if I come to the PC and I want to configure the PC, oops, what happened to the PC configuration? There, desktop. Can you all see it? Yeah. IP, I'm going to put 192.168.1.10. Yeah. Subnet mask /24. This is correct. And the default gateway 192.168.1.1. Why? Because this is the IP address of the router interface. And this is same default gateway, which I give to what? I give to the switch, default gateway. This is all I need on the switch. Mission accomplished on the switch. Now, let's come and also configure this PC now. Okay. Now, the IP address here is 192.168.10. Subnet mask is correct. Is it correct? Because I told you .10. Can you see on the packet tracer? Can you see it? I wrote .10 here. I told you it needs to be .10. I give you, I tell you. If I don't tell you, then you give it any valid IP address from that network. Any valid. You have from .1 up to .254. .1 we gave it to the router interface, so you can't use it. So from .2 up to 254. Okay, but as we will see in our exercise, I'm using .2 for the switch. And I'm using .10 starting from the 10 for the PCs.
192.
And the default gateway.
198.2.1.
Okay, I'm lazy in typing, so I'm just going to copy and paste. Okay, .2. Okay. Okay, there you go. Right, so let's go to the switch. I want to configure the switch. So enable conf t. So I'm just going to open, you won't be able to see that notepad file. I'll just open S2. Okay. And I'm just going to copy it. Control O, Control C. And I will paste it here. Done. Okay. Now just show run just to make sure. Host name, the secret, no IP domain lookup, and VLAN 1 is 2.2 and default gateway 2.1. Everything is there. In the banner, authorized user only. Sorry? C? No. You know this special character? I'll show you here. Special characters يعني هذا موجود on the keyboard. So the special character. So when I typed, for example, let's say conf t banner MOTD, I put a hash as a special character. Then I wrote my message, and I ended my message in a hash. This hash will be translated by the Cisco iOS into the caret symbol C. So it's not a spelling mistake. The caret symbol C is actually represent the hash. Okay. Okay, you can use anything which you don't use inside your message. I can even use a letter in the alphabet if I wanted to. If I make sure, for example, I don't use this letter in my message. Yeah, can you see that? As long as it's not in the message. Right, so I'm done with the switch. This is the command I told you about. So WR is same as copy, run to start. Well, does the same thing. Okay. Or WR is very quick, does the same thing. So we're now, what we've done, this PC1, PC2, this switch, we've done the router now. Let's do S3 and S4. So very quickly, I've already also got those files ready. Conf T, and I will copy S3's. Okay, paste. So S3 is done. And then we go to S4. Control C. Conf T. Is everyone following, Shabab? Yeah? Okay, paste. Now I'm done with the switches. Now I have only 2 PCs left.
So why did you write WR? To save.
To save. It's like copy run to start. Yeah?
Sorry.
Okay, so let's configure this PC3. IP address is .10. Okay, it's correct. /16 is correct. And the default gateway is .1. No, for default gateway is .1, which is the router interface. Yeah. Yeah.
So when you configure the router, it already knows the subnet mask. So when you enter it on the PC, it already knows the subnet mask. So
it assumes a default subnet mask. Assumes. Sometimes it's not correct, so we have to make sure. So I did not. When I did this, I also looked at this here. I saw /16 and made sure it is the correct. Because if this was different, not 16, I need to manually edit it. So be careful. It will assume a default, but the default is not always correct. So be careful there. Okay. So let's come here now to this one here. This last PC to configure. This is a /16. And it's a .10. And the subnet mask is this. Right. What can I do now? Let me just save this. Can I do any ping now? Is that okay? PC1. Let's say on PC1, Ping.
No.
So can I ping my default gateway, which is 192.168.1.1. It's working. Excellent. Can I ping PC2,
I think so. Yeah, that's right.
which is 2.10?
Yes. Sir, we can't see it. Please. The first time on server. Oh,
I think okay.
no. 20,
Yeah.
25% loss.
Ah,
25%
Okay.
loss, yeah.
Why is it that I could ping PC? Okay, let's do something else. Let's do something else. Let's see. Can I ping PC3? So it is 172.17.0.10. Destination host and region. Now let's have a look, see what happened here. Let's go to the R1 is going to give us the answer. Cisco enable class. Now remember the whole idea, the last topic we talked about was the switching frames or frame rewrite when we go from one device to another to another. And one of the operations that a router did when it receives a packet, it decapsulates, remove the header of the MAC address, and then looks inside the packet. The packet looks at the destination IP address, says, do I know about it or not? If I know about it, I will forward it. I will switch it out of my exit interface. But if I don't know about it, I will drop it. Let's say, what does R1 know? Why did it work for PC1 to PC2, but it didn't work? But the command is show IP routes. Okay. For the time being, just ignore the else. The else just basically tells me this is the host IP address of each interface. C, we'll just look at the C's for now. It says R1, it says I have 1C, 2, 3. It has 3 directly connected networks. I think someone is, yeah, okay. The first one is 10.100.1.0, which is what? Which is the serial interface. Is it directly connected? Yes, it is. The second one is 192.1.0, which is connected to SG00, another directly connected. Brilliant. And the third and last one is the 2.0, 192.168.2.0, which is this one. So it has 1, 2, 3 directly connected networks. And this is reflected in my routing table. It has 3 entries of directly connected. Since PC1 is coming from GI01, sorry, GI00, I beg your pardon, going to GI01, both of them are directly connected. It says, hey, you're part of the family. Both what is coming from, what is going to, is coming from an interface which is directly connected to me. It's in my routing table. And is going to another directly connected network also in my routing table, so I can route between you. Hence, this route, this particular ping was successful. But when I tried to ping 172.17.0.0, where is it? Where is it in my routing table? Is there an entry for it? It says, I have no idea what you're talking about. I don't know about a network called 170.17 or 170.16. I have no idea where it is. Yeah? The only way we can reach it is going to be next class. But anyway, I'll tell you what, very quickly. We need either a static route and with dynamic routing protocol. Static route or dynamic routing protocol. And this is what is left. This is what is left. Very quickly, what we have covered today. We have finished the basic configuration of the router. We have covered the concepts of what is a dynamic routing protocol, what is static routing, benefits, advantages, disadvantages of each. We talked about the concept of a default gateway. We talked about the concept of frame rewrite, which is basically how a frame is rewritten when it goes through one device to another. We noticed that the MAC addresses, they keep changing from one device to another. The IP addresses, source and destination, stay the same throughout the path of the journey that the packet takes. Okay? And we noticed today that if you are routing packets between directly connected networks, the connectivity is there and it works. For remote networks, it doesn't work unless we have a static route or a dynamic routing protocol. And this is going to be done in our next class. Okay? Thank you very much, gentlemen. This recording will also be put for you on BBLR.